Whoops, I forgot the mic. Welcome in, everybody. How's everyone doing today? Hopefully music isn't too loud. There we go. Right. So, yeah, today we're gonna be working on kind of a smaller side project. Something I've been working on for a couple of days, just a little bit in the background. As a kind of break from the pathing library, and then we should have time, because I don't plan on, finishing the project today, or, the side project today. We should have time, so, if we do, we'll do some work on the pathing project. Sounds good? Cool. Let me just make sure everything works. Yes, you're capturing the right one. And yes. Okay. I'm gonna switch this to that. Okay. So this came about a little bit because I got really interested in how archive formats work. So an archive format is something like a .zip or a .tar. A lot of the time you'll see .tar, .gz. That's because zip files, when they take a file, so what they do is let me see if I can find it. Sure, here. See, I have my folder, and inside of my folder I have some file dot, yeah, I can spell, some file .txt, some script .py, some inner folder, and then inside of this inner folder we have some program Java, and some class. Lovely. So, oof, that's loud in my ears. So let's say this is what my folder looks like. When I compress this to a .zip file, what it does is it says, okay, well, let's look at the folder. So if I were to take this entire folder and have to represent it as a single file that can be transferred across the internet, how would I do that? Well, somehow I have to figure out how to record what is inside of each folder, or what is inside of the folder, and then what is inside of each file, and then inner folders and stuff. So normally what they do is they'll say, okay, look, so my folder .zip something like this. Zip. I don't know what the zip files are written in pure binary, but that's dumb. It's hard to read. Well, okay, no, it's not dumb. It's very smart, but it's really hard to understand. So this is kind of like maybe what's going on inside there. Is it says, okay, well, my folder is a type, is a directory, and then it'll have like permissions and stuff. I don't know, it'll be like something, some number, 1, 2, 3, sure. Wait, permissions are represented as an octal, I think that's the word. Whatever, it's fine. So my folder, type, directory, permissions this, I don't know, mdate. This is like the data was modified. This is like something. Maybe it'll have an access date. Be something like cool. Okay, the next thing is my folder / some file.txt, and this is a type file firms whatever ... and it'll be like content, and then it'll have the raw binary content. It'll be, I don't know, like, and so it'll keep doing this for every file. And then when you get to like some, if you get to like some program, it'll be like, so my folder slash some inner folder slash some program.java. Right, same, it'll be the same kind of idea. And this is cool, but if you're going to represent everything as a binary file, which you will because you want to represent every kind of possible file, and every file can be represented as just raw binary, that is a lot of stuff to hold. So zip files, what they do is they take this and they're like, okay, well, compress it. They use a compression algorithm. I forget what it's called. Let me actually look that up. What compression do zip files use? Okay, so it's called the deflate compression method. I don't know what that is. Basically, it takes all the zeros and ones and it makes them fit in a smaller space than they would have otherwise, which helps with the storage. And then when you want to retrieve the files again, you uncompress it, and this is why it's important. It's a lossless data compression, which means none of the data is ever gone. It just takes the data and makes it fit in a smaller space. Whereas you'll find some other methods, usually for photo compression, that are lossy, because they don't keep all of the data. They just keep most of the data, enough of the data that it looks basically the same. Or another one you'll see, this is with audio. Audio compression is almost always lossy, because the average person can't tell if it's a lossy or lossless audio compression. I guess we'll finish talking about this right after we come back from ads. But for those of you who are still here, I'm working on something like that. I don't think I'll do any of the compression, but I will be trying to implement a couple of different ways that you can handle storing an entire folder as a single file, and then retrieving that folder from that file. And so that's kind of the mini project. Rename this is codec. All right, the other thing. So this is, what is this? Oh, right, yeah, no, that's fine. What? Nope, stop it. Import ABC, class database, sure, base, c.abc, at static method, at abc.abstract method, def, thing one, thing one, thing two, lovely. So class A of base, def, thing one self, print thing one, def, thing two self, print thing two. So it does have all of the things, but does it work? So if I say if name is main, are you happy? You are happy. Okay. Are you still happy if this is a static method? Nope. What the hell? Stop it. Like that. Hey. Hey. You have everything. As you float by the storm is the you meant the world to me. When you cry for me, for you so loud, the pain is over. Oh, interesting. I didn't know that was a thing that it could do. But I guess it can work with that. Okay. Well, welcome back, everybody. I was explaining this, right? Because that's a lot of binary. What zip file does is it takes that and compresses the binary to fit in a smaller space, which is cool. The other format that you'll see, my folder.tar, tar doesn't compress. It's the same idea, same exact idea, but it doesn't compress this binary. This binary gets to stay as large as it was originally. Obviously, that's not always a great thing. So a lot of the times you'll see .tar.gz, which is you take your folder, you turn it into a tar file, and then you take the tar file and you run it through a compression software called gzip, which gives you a .tar.gz, which first gets uncompressed by gzip, and then gets dumped by tar. Which I don't know which one is better. I'll be honest, you see tar gz a lot with like Linux software. Or like you see it a lot with like developer software, like stuff made for developers. You don't see it as much for like user software. So I don't know why that is, but it is. So that is kind of the difference between the two. They both do the same thing at the end of the day. A .tar file will be bigger than a .zip file. A tar.gz file, I don't know if it'll be bigger. I guess it depends probably, because I assume gzip and deflate or work differently, so maybe they work better on different kinds. I don't know. It's all like, well, I mean, it depends on exactly what you want. So ABC also depends on like what you have as your starting. Is ref. Actually, I was always curious. Does I don't know any languages actually do this. Yeah, this. Okay. So you just use else. Wow. That That is really simple, huh? Codec dot can code file path. Oh, oops. Codec can't. Yeah, dot. Wait, what? No. It's codec dot can. What would it have been? Codec dot I guess first I should figure out what base codec plus codec base abc dot abc. Codec dot is reference. What syntax do we want to use? Because we can say codec dot. Okay, so the idea is that this will be a list of codec base codec Yeah, is ref is fine. Is ref can and code or can... Wait, no, can extract file path from... Nope. Path. pc.abstract methods def extract file path works. We'll build a couple other ones later. Method, abstract method def build. Wait, data is a dict. No, file path is a path or a string? No, file path is a path, that's fine. Build returns nothing. What else? Oh, right, load. That's the one that I want to use, load and build. Load, so is ref checks if the string is referring to this file, because maybe there's like multiple ways to do the same thing. Oh shit, hi Ghost. Bye, okay. Bye Ghost. Yeah, so as ref checks if the name is like a string that can refer to this, can load. Check, quarks, doesn't get codec. Codec. Codec base. Hi Bennett. How's it going? Oh shit, StreamBot is known. Fuck. I always forget something. And, oops, sorry about that. The StreamBot is usually always on, but then I forget sometimes. Do I have a way to force it to do? I don't think I have. Whoops. Ben, it's going good. How about me? I'm doing all right. We're just working on a small kind of like side project to take a break from the pathing library that we were doing before. Load file path. Yeah. And I don't plan on like finishing this, just kind of working through it a little bit, so we should have some extra time to go back to the other one. Codec of codec. Return dot load file path else raise failure. Oh, like that. Yeah, name. This should return a string. Dot. This returns none. Not none. Not name. None. Bennett. Hello world. Yeah. Yeah, kind of. Okay, and bye, Bennett. Do I? Oh, why is it? I don't like it. I don't like it when Twitch changes how the redeems are laid out. Now it looks all funky. Maybe it's just because it's small. No? Or potentially this is just OBS. I have no idea. Quargs. Can load should take quargs. Load should take quargs. And then build should take quargs. And quargs dot get over right false. If we set overwrite to true, wait, no, false, and not this. That's fine. Actually, I don't even need to have an implementation for you. There you go, like that. Mm. Um, parts of, wait, no. Deck. Oh wait, no, it just returns. Never mind, I don't even need the else. Now I gotta say goodbye. Wait, no, we don't have this now. For ref. Yeah, that's about right. Equals like that. So if you pass in a path like is just any kind of like, it's a string or any object that can represent a path. So like mainly that's string and then pathlib.path, but there were probably others. So if you pass in one of those, then it'll send it to the parse data with whatever quarks is keyword args. So we'll send it to here. And so if instead of quarks you passed in codec, then it will try to find the codec that matches the one that you did. So past codec quarks dot pop codec. Codec. There we go. And now this is kind of where the meat of that comes in. So there's a codec base. abc.abc. c.abstract method. Data ref get any. All right, I need to. Do I need any, or should I have it load something else? Typing from collections import name. Oh, wait. Typed dict, I think. Is that collections? Where's typed dict from? Nope. Class info typed diff is from where? Because I know. Is it typing? Really? No, not codec base. This is a file info class dir info type date pass. Data. Contents. Wait, no, it's a dict of stir info. All the breaks that out and now letting go, Oh, okay. Wait, archive data. So like this. Okay, so you don't instantiate these. These are, it's just kind of like a framework for that. Okay, fine. It's just a new file. Yeah, okay, no, this is just not gonna work. Version string. Do we do that string? Yeah. Yes. From OS. It's a string. Base 91. Yeah, I will in a sec when I use that. So real quick, an interesting thing about programming stuff is we'll remove this. I guess this will change depending on the actual, depending on the kind of system that built it. So this will change. These are all standard, and then this will have to be like a kind of a subclass of that. Right, what was I saying? Cool. One of them that I want to do is encoding a file in JSON. JSON is kind of this format. Fuck. Oh, it broke. I had a break. Hi, Suo. How's it going? Thank you for your daily cast. Why did it break? Sorry, I'll look at this real quick. What broke? Good at Oh, it did none of this. Oh no. Uh-oh. Something in here broke. I'm sure y'all can see this. Might as well. Come on. Full screen. Read-only span is defined in memory, right? Where are you referencing? Okay, wait, never mind. All right. Okay. Delete that. reference. I need to add the reference from a file. No. Here. See, I knew something. I moved the file, or where like streamer butt was stored, and now it has broken everything. Memory. Sorry about that. Memory. Yes, this. Happy now? You're happy? I don't know why. It, for some reason, can't find some of the files that it should be able to do automatically. It's dumb. Oh, sorry about that, Suo. But yeah, how's it going? Welcome in. Sure. Give me this, rename to a .json file. JSON. So, JSON looks like this. You have, I don't know, hello to file, I don't know, path to file, right, stuff like this. Because of how JSON works, is that when you actually like look at this, it is just a text file that has a special, a file extension to show that it is a text file with a certain structure to it. What that means, though, is that when you look at how this is represented in binary, it is represented using Unicode. Unicode is a way of representing all kinds of characters. So like first you start like ASCII. I'm sure some of you have heard of ASCII. That was one way of representing 100 and it was 128 characters. Let's see, ASCII chart. Most of these characters weren't printable. Not most of them. A couple of them weren't printable. ASCII control characters. Yeah, the first 32 characters are what are called control codes, and they, handle certain things for, like, I think this one says printers. There's a backspace character here. There's, should be return is in here, or carriage return. Carriage return here. So a bunch of stuff that you don't actually print. And the negative acknowledge, this was just a character that you would transmit to some system to say, yeah, no, not, we didn't get that, or we don't know that. Acknowledge is, the opposite of that. So there's a bunch of characters you can't print. But then after that, you have the other characters that you can. And these are all the characters that you know. Not all of them, but all of the kind of standard characters, and delete, which is also not a printable character. Well, it's not a printable character, but it kind of is a printable character. Because it's treated like a printable, but it isn't really. And then there's the extended ASCII, which goes all the way up to 255. So these are the like 8-bit stuff. It goes all the way down. So you get a bunch of other characters that you can use commonly. Which is cool. But that means that if I'm going to write a bunch of zeros and ones, right, in binary, 10 takes up 1 bit. In ASCII, 10 takes up 4 bits? No, 8 bits? To the... Wait, no, it's not 8. To the 4? Fuck. 6. Is it 8? Oh, it's 7. Right, because 2 to the 0 is 1. It takes up 1 byte, which is a lot more space. So a way that people have found to kind of reduce that load, if you're transmitting like binary or something over a Unicode or like ASCII text system, so like this, is you can encode the binary in base 64, which is just kind of a map of like, well, if I see, it's like base 64, I don't know if I have, whatever, so. Oh, wait, no. Wait. There. So this takes your binary. Wait, what? This is binary. Yeah, it takes binary and then turns it into a bunch of letters and numbers that you can work with. And these, see, each of these characters take up 4 byte, or take up 1 byte. Each of these characters also take up 1 byte. But there's a lot fewer characters, which is a benefit of base 64, is that you turn a lot of characters into very few characters. Some people have gone even farther, and essentially like the maximum that's kind of safe for use in most systems is called base 91. Base 91. What? Wait, no, not to, that's not what I was looking for. No. Yeah, that's not what I'm looking for. Come on. Okay. So, hello world. If I want to grab this and represent it in binary, print dot, oh, B. You put a B in front of it and it'll print B. Wait, no, it still prints that way. Dot decode, I think. Nope. Encode. I think we do this for a normal string. Whatever, I think. Nope. For block in and block dot 2 bytes. 4, I think. 8. Oh, int. Oh, block. Base equals 2. What the hell? How do you print the binary of a string? Now I'm confused. I print binary of string. Print hello world. There. Yes. There. Binary. So that's a lot of binary characters. If you do it like this, this would take up, well, that many bytes. If we convert it to base 91, it takes up this many, it takes up, well, this many bytes. Which doesn't look like that much of a big deal, because if you look at the hello world itself, it is, it's shorter than that. Is it the other way? It is the other way. Let me see if I can find Python base 91 library. There, like this. Okay, there. If I take import base 91, yes, I need you to install that package. Yes. Base stir equals hello world. So if this was like in a file and I were to read it, it would print something like this. Base stir. I print base 91 dot encode dot encode. This uses up way few characters, which for like the actual like alphabet, it looks like it makes it longer, which it does. But if I have an image file that can't be turned into alphabet letters, it shortens that a lot because it's not just text, it's like an actual image or something. And so instead of writing this many characters and then having each of those be 1 byte, I write this many characters and each of those is 1 byte. So in theory, well, not in theory, not just in theory, in practice, it is much, much smaller to encode things to base 91. Oh wait, let me see if I can have it actually. Base 64 is installed by default. Import base 64. I don't know if it'll actually make this, if it'll actually be shorter than base 91. It should. Or longer than base 91. Base 64 dot encode base dot encode b 64 encode. I think that's the one that we want. Yeah, so it's a tiny bit longer. Whereas this, well, it's a lot shorter. And well, it's like what, couple characters, 3 characters shorter. It's not that big of a deal on the small scale. On the large scale, it is a much, in practice, it means it's a lot shorter and hopefully more compact to transfer than just dumping the raw binary as text itself. With all that being said, that was a complete side tangent. Sorry about that. Right, we were doing this. Let me put directory above file. So wait, no pass here. Here we need terms. That's just an int. Ooh, wow. Time. String. How do I want to represent time? So ISO format, which is year, which provides millisecond access to M time, A time, C time. Okay, so we probably just do it to the second. Okay, what is C time? Access time modified and change. Oh, Okay, so we can't include ctime. Windows and Linux provides access to a time and m time. Okay, yeah, because then there's probably a kind of a system for that. Yeah, m time should be string. Wait, no, that'll be with the file. Created at a time, m time, a time. What else? What else do we need? We need. Oh yeah, hidden. Does this have kind of an equivalent on Linux? Does Windows have equivalent in Linux? Okay. Cool. Could be okay. Then one other thing. So owner group IDs and stuff. archive. Alright, I need to go to the bathroom. I will be right back. Let me turn up the music for you. And yeah, wait, do we need to run ads in a sec? No, we just ran ads. Okay, never mind. Alright, see you in a bit. And we're back. Desktop. Okay, so which of these? Okay, so read only is only for files. Archive, what else? So hidden, system, archive. Not content indexed. Not indexed. Hidden system, so system archive, not indexed. Not Max, Mac. I think they're both Unix systems, right? Uh-huh. Okay. Equivalent for Linux Mac permissions. Read, write, execute. Oh, that might be an issue. Okay, well, it is something to think about. Okay. Do you want to do this or none? Because Unix uses a certain permission scheme. I think you'll see this called like octal. So you'll see like params would be like 755. Let me see if I can find something about it. Linux params octal. It's like this. So you'll have an owner, you'll have group, you'll have public. So read, write, and then execute. So it's octal because it's kind of like binary. Essentially each number is, so execute, if you have execute, then it's 1. If you have write, 2, and read, then 4. So if you just add those together, you get 7, 6, 5, whatever combination you want, it's all unique. Same for group, public, and then owner. So all of these can have any of these permissions. And this is called octal because this, well, it's a kind of an 8-bit system. Not 8-bit, it goes up to 8. But it's kind of 3 bits for each of them. Yeah. But Windows doesn't have that, so I guess OS specific say picked. Wait, no, this like that. So those are the only ones that are universal, I think. Because everything else depends on the OS and is recreated a little bit differently. So M time and A time are the only ones that are universal between the two. String, A time string, and then this is a checksum, which is a checksum is kind of how you make sure that when you transferred the file, everything happened okay. So sometimes if you're downloading files, you'll be like, yeah, so you downloaded the file. Now if you want to download the checksum, you can. And basically what it is, so there's an operation you can do called hashing, where if you take the original content of a file, sure, like this, and my file equals this, print hash my file. So this will print a thing. I don't think hash works like this. I think I need to, it's kind of like this. So basically, if I then grab this number, I don't think it'll be the same, but we can check. If I do this again, yeah. So it prints a different one because how hashing works in Python natively is you hash the memory location, which obviously changes. Import lib. I think that's what I want. Python MD5 56 hash checksum. Basically, you take it can be a huge file, and it'll get contracted down to a tiny set of bytes. SHA-256 is 256 bytes. And then you compare the 2 bytes. So when you receive the file on the other end, what you'll do is you'll take that file, and then you'll hash it again using the same algorithm. And then you'll look at the 2. You'll look at the provided hash, and you'll look at your hash. And if the 2 hashes are the same, the file is fine. If the 2 hashes are different, the file got corrupted. Or something went wrong. Somewhere in the process, something is corrupted. And so you need to redo the hash. Or you need to re-download the file, redo what you need to. But that's how you make sure that the 2 files are the same without just literally downloading the file twice and comparing it. Is you hash it once into a tiny set of bytes, and you hash it again on the other side, and then you compare the 2. Hashes are very lossy, right? They don't preserve all the data. So it is possible that 2 hashes that don't hash the same object give you the same hash. But this is called hash collision, I think. It is a very, very low probability of that happening because of how hashes work. It is basically impossible. So that's how you kind of make sure that you check the integrity, which is why it's called the checksum. This hashlib hashlib.sha56.hex digest. Okay. So if I make this a bytes hashlib dot what SHA-256 SHA-256 hex digest, and then we'll see what this outputs. So it gives me this, right, print this. If I do this again, it gives me the same number. The really great thing about hashes is that if I change even a tiny bit, the hash is completely different. I changed a 2 to a 3, and the hash is entirely different. This is why hashes are also used for like security and stuff. Because hashes completely change even with a tiny modification. Hexadecimal. What does digest do? Oh, no. Yeah, so this is why I use hashes. Same way that like hashes are kept in, that's how a lot of databases will keep passwords and stuff. Is instead of actually storing what the password is, they'll take the password, they'll hash it using very complicated math that is a lot more secure than what I just did. And then they'll store that. So from that, it is virtually impossible to get back to the password. So if the hash were to be leaked, it is virtually impossible. Not completely impossible, but it would take you many, many years to get back to a password. And it is also virtually impossible for you to put a different thing into that password, into the password like field, and have it give you the same hash, unless it is exactly the same as the original password. It's another application of hashes. I forget exactly how they work, but they do. That's all I know. String checksum type is a string. Yeah. I think the standard is we'll probably do. I mean, I guess test. No, give me this back. MD5. What is the difference between the two? Oh, MD5 is smaller. MD5 versus 256 for checks. Okay. It's also interesting. So there are apparently known vulnerabilities with MD5? Yo, thank you for the follow. Envomer? Uh, hopefully I'm saying that right. If not, please feel free to correct me in chat. Yeah, welcome in. Thank you for the follow. I appreciate it. This is okay, developed by 1991. Damn, these algorithms are old. Fast and efficient, making idea for various applications, however. Okay. So, like, for security, it's not quite what you would want, I guess. I think I'll probably still use SHA-256. Close enough. Well, yep, I'll take that. Is that good, or would you, like I said, if you prefer like a different pronunciation, I promise I do try. Yeah. Wait, oh, I forgot something. Give me just a sec. Nope, not that. There. There we go. Okay, yeah. So data integrity. If you check the integrity of files transferred. Checksums. Yeah. Okay. Okay. Hopefully this rabbit hole doesn't take us a while. MD5 vulnerabilities. Okay, how does MD5 work? Pen padding bits. Penned length. Okay. Oh, yeah, I don't think I asked. How are you doing today? What did I say? Envomer. Envo? Was that fine? What the hell? Okay, sure. That's why did, it's normally supposed to only come up in like games and stuff, I think. Sure, I guess. My office software is a game. Yep. Okay, so we had padding bits. Use the 4 buffers. Length of each buffer is 32 bits. In 4 rounds. In the first round, 16 operations were performed, 16, 16, and 16. We apply a different function on each round. For the first, we apply F, G, H, and I. B and C, or not B and D. Uh-huh. Okay. That's not fucking helpful. That's not an implementation. You just said, hey, go do the MD5. You can't call that an implementation. Okay, well. Sure. Okay. Oh. Okay, so we can rotate to binary. We padding. Yo, thank you for the raid, Dino. I swear to God, I'll fix that. Oh, welcome in, Dino. How's it going? Thank you for the raid. I really appreciate it. How was Minecraft? How was Minecraft? Sorry, give me just a sec. Is this here? No, I know where it is. I think. Yes. Litusha? No. Okay. Minecraft was good. You didn't beat the challenge? Oh, well. Hopefully it was fun. A lot of chaos. Chaos is good. Love a good bit of chaos. Marie. There we go. Maybe. There we go. It's at least one of the things it's supposed to do. We had a hard time finding the Nether Fortress. Yeah, I can see that. I haven't beat Minecraft, so I have no idea. But it sounds like a lot of dying. You did the like chat redeems, right? For in-game stuff. They add more to themselves than to redeems. Ooh. Sorry, my brain froze. I forgot what I was gonna say. 10 points, bits, subs, all ran through StreamerBot. It worked the majority of the time. You know what? That is all we can ask for, right? It works most of the time. Probably. I'm glad it was fun. Right. It was a pretty long stream, right? So if you need to, go do self-care stuff, take care of yourself. Dying is in fact bad for your health. I know. It's crazy. Please do that. Again, I appreciate the raid. Alright, we're talking about this. Well, I got petted with a single one, then enough zeros to bring it up. Okay. Yeah, I don't think I can hope to get that. It works. It's good enough. Thank you for the hydrate, Loris. Yeah. I know you'll be lurking for a bit as you finish up stuff before dinner. We'll have a good lurk. Hopefully the stuff that you need to do goes fast. And hopefully you have good dinner. Good food. Thank you for the stretch, Dino. Yeah, 56. That's fine. I assume it doesn't, because that's stuff that isn't like... Yeah. Okay, that's what I thought. Can you get creation time? This Windows store file folder creation time. Or just modified time. Yeah. Sorry, I forgot to do this. You know, Raiders, we're still here. I'm Shadow. We do a lot of coding, programming stuff here. Sometimes we play games. We haven't played games in a bit. Right now, we're working on a small side project that is becoming less small, as it always does. Kind of a custom archive format, like zip or targz, if you know what that is. It's like that, but worse, just to kind of learn how that works and to experiment with it. This Linux store file folder creation time. Okay, so that is another thing that will be here. Class Windows for info type div. Info. So it stores those and then the Windows specific ones, which are hidden status, I think. Hidden. Cool. Oh yeah, and then create time as a string. And then what else is there? There's hidden status. I don't know what else I can store. Do directories have read-only? I thought that was file level. Windows directory level read-only. Do folders have them? Ah. Oh yeah, items. Size 8. Total items. Wait, item count. Read only full. info. You don't have that. So terms is an int. Yes, it is. Perfect time. Unix. What's it called? It is folder level owner ID group ID. Okay. So then UID is an int. Is it an int or is it just like a string, like the name? UID string or int. For Unix UID and J. Okay, so we have so this is the base kind of info that all folders can have. This is Windows specific, and this is Unix is I think Linux and Mac are both Unix. Linux and Mac Unix systems. Okay, so they're both, I think, Unix compliant then, so they should both have this stuff, I think. Windows directory security IDs. Okay, how does that work? No, like for directory permissions. Because I assume there is some way to do it differently, but oh. Does oops. Loris, you gotta get a few things done before bedtime, so you're gonna lurk for a bit. Thank you for the lurk, Loris. I hope it goes well. And, you know, when you go to bed, I hope you have a good eep. Windows have for normal to find members societies for an account. Okay, I'm going to switch this off for just a sec. Yeah, just to make sure. You know, user and okay. Interesting. So it is something that you can set and work with. How to set directory permissions. Windows SID. Go away. I'd like to have take back everything. Sorry, again, I'm gonna switch this, just for security's sake. Properties? Security, yeah, there, okay. Desktop scene. Okay, so that's fine. So and I can store, I guess, each of those as so you do have perms, it's just a different kind of permission. This is a of string to a, I mean, I guess you could also represent it as a number. And one, two, three, 4, 5, 6. Okay. Okay. So it is something here. Okay, then this needs to just go into its own file then. Lovely. Is Python file data dot struct. Nope. Types dot py. Good enough. Typing import type dict, and then what else? Okay, lovely. I don't need you, but from dot types import archive data. What else? Windows type dict. We should just do it like that. So what do we have? We have full control pool, modify pool, read exec pool, read pool, write pool. List. Oh, wait, no. Yeah, okay. So, wait, what's different between that and here? This is says full control modify read and execute list folder contents is the only one that I think is different. Wait, full control modify read execute read write special. I don't know how to do special permissions because I don't know what's there. So I'm just gonna not even. Windows plus Windows dir params Windows params list and what? List contents. Cool. I think I'm gonna hold off on doing the specific ones, but they are here, so I want to make sure that I have them. Owner string terms, no, because you get the normal permissions, did a great time, hidden, read only. I don't think I'm gonna use most of these. I think we're just gonna stick to this, and that. Oh, and then file, and then the actual contents. Contents, which is an access object. Did I define an access object? Yes, I did. It's right here. Here. Port ABC. Any. Class. String ref. Data ref base. Def. This is just a string. Self string. Wait, data. Nope. String. Self.data equals data. Def get return self.data. Wait, file ref. Okay. We take, this should be a file path. File path. Def get. Turn f.read. Wait, this should be a path load.path. Path load.path. Okay. Time is it? Yeah, I don't know if we'll be getting to the pathing library. Got a little too lost with this, but I guess just os.pathlike actually. Pathlike rather than this one. Or os. I think that's the one I'm looking for, right? Did I spell that right? Portalocker time. Okay. Just the basic locks. Portalocker dot lock. Okay, lock flags. Okay, that's documentation is very old. Okay. Okay, so yeah, so what we probably want is a shared lock. Okay, so lock. Actually, do we need this? I don't think so, actually. I think we'll just do it like this. Self-dependent eval equals true. I think this is a runtime error. Self.eval. Okay, I think that's all we need. Those are kind of like the basic things. Okay, Install portal locker. Data equals. Oh wait, no, we still need types then. Since that lock type, I think. Give me a second. What is this? Oh, lock flags. Lock flags dot short. Okay, what meta info do we need? We need version, which created at, which will be datetime.now. Date time import date time. Date time dot now dot ISO format. I think this is right. So if I go to test from, nope, not capital, from datetime import datetime print. What the hell is ISO format? What? Date time ISO format. ISO date time. Oh. So the T separates the date and the time and everything else. Okay. So time spec seconds, and that'll only give me the seconds. Perfect. Oh wait, no. None of this matters. Archive data doesn't need to include any of that. Types. So you do need meta info, but this is separate and this goes here. Yeah, we don't need that. We will kind of, but not really. Yeah, wait, that's fine. We need file info, dir info, like that. Because you don't need the metadata until wait, yeah. Types, right? These come from types. All right, y'all, I need to go to the bathroom. I will be right back screen. There, that one. And turn on the music again. There we go. All right, see you in a bit. All right, and we're back. We have this. Okay. So we don't need that immediately. We do need so we start at the if not can load raise okay, we have no more valuers. If it is, then what do? We have path.walk. Path lib path walk directory. Reading directories. Okay. So test. New test there. Test file 1. New file test file 2. Test dir2. Test file 3. If I just keep going, I assume it doesn't see any of this. Test dir3, and you just empty. Okay. I import from pathlib import path path equals path of test dir. Do you have a recursive iterator? I would assume you do. Not walk. No, not wolf. Walk. What does this say? What does... Okay, so you can use walk. Walk gives you... So this is the current directory. It gives you all internal directories and then all internal files. Then it walks the next directory. So if I were to make a copy of this, sure. Try this again. So what are you going to do? You walk this one, and then you see tester 2. Oh, and then you walk all the way through, and then you walk here, and then you walk all the way through. Okay. Is that kind of like exactly what we want? Kind of. For item in file path dot. Do we want this? I mean, we can just do walk, right? Oh, and then ret equals this. Item dot, wait, item of 0 dot Okay, so just string and that gets you the directory. Okay. M time and A time are pretty universal. Since they're full. Yeah, okay. Can you get M time from a path? Pathed path M time slash A time. Okay, so what is T A time? Date time, import date time. Dot not Unix. Date time from what? Oh, Python. Oh, from timestamp. Okay. From timestamp. A time, M time, A time is there. Dot ISO format times spec seconds. A time. Oh, wait. What does this return? Oh, it shifts this up to the nanosecond? Does systems provide time to the nanosecond? No, I guess nanosecond really, because I'm pretty sure that's what NS stands for, right? Oh, I mean, I guess then might as well. It should be like a million or something, right? Child. Something like this. You happy? Nope. 3. There you go. So divide by a billion. Okay, lovely. Dot stat dot ISO format. Okay, so yeah, so you don't store up to nanoseconds. time spec equals seconds plus m time oh nope. One, two, three, 1, 2, 3, I think. Like that. There we go. Yeah. Okay, what else do we need? We need to check if it's a directory. Is true. And then now what's the directory thing? Item count. And then what's the last one? The last one is item count equals then item of 1 plus then item of 2. Okay. Which one is it? It is an item. Gives me 3 values, right? Yeah, so these are all the directories. So these are all the files. There's going to be an ad in a minute or so. Yep, when you go into the ads, when you come back, I will catch you up on what you missed. Probably won't be much, but, you know, in case there is something big. Ooh, actually, that is a big question. Do I even return like this, or do I keep a bunch of... No, I should return this. Content square equals quarks.pop. Hidden blob. I think we can probably do that. Copy. Quarks. This comes from where? Typing, right? Yes. is a literal what? Direct copy hidden ref method. Block. Class file ref enum yeah enum stir enum auto as auto copy hidden ref lock file ref locked ref Oh wait, now we need to store a state though. none. Instance is none. Add property that comes from where? F you know. Oh, okay. So it's a class method. Same idea. Is this at class method as property? Diff cls if temp do. Copy. Temps. We will use that in a sec. This equals 0. Then self dot axis map equals this. Yes. File path dot is file. Does not exist. Okay, that's there we go. Okay, oh shit. I need to end stream here. So that is going to be it for today. Thank you all so much for watching. I really appreciate you. Yeah, and thank you for sticking through the ads. Let me see. What we got? Yeah. Dino, I don't know if you're still here. I don't think you are. But thank you for the raid. Thank you, Raiders, for popping in and staying. Socials. I have some socials. Kind of. There's a Discord. Announcements, schedule updates, stuff like that. That goes there. If you want to talk to me outside of stream, that can happen there too. And yeah, I post my VODs on YouTube. This one should be up like today, probably. I want to do edited content soon, but I don't have the time for that yet. So in the future. Next stream should be in a week, maybe. I think I need to make sure. But it should be in a week, same time. 1:30, 2 p.m. PST to 5:30 ish. Is that it? I think that is it. Remember to take care of yourself. Dying is in fact bad for your health. And let me see if we have someone to raid. All right, try. Let's see if someone's doing other programming stuff. Sure. Sorry about this. The stuff is slow. Okay. Well, I don't know if that'll load, but if it does, we will rate them. Yeah. Remember, take care of yourself. Dying is bad for your health. Drink water. Eat food. Get rest. Try not to overwork yourself. Now, sometimes it's hard, but it is bad for you. And okay, yeah, I think we'll just rate shy. Cool. There we go. Those are all the things. I will see y'all next time. And bye. Shit. The message on the top is if you aren't subbed. Message on the bottom is if you are. I forgot about raid message. Okay, now. Bye.